Hello everyone, my name is Param Ramesh Parsewar. I'm from IIT. I'm pursuing BTech in computer science there. Today we are going to solve the mock test 22, the physics section, and we will start with it. So here on the screen you can see question number 61. The question says a particle falls from a height h upon a fixed horizontal plane and rebounds. If E is the coefficient of restitution, the total distance traveled before rebounding has stopped is. So in this question, it is given that there is a particle which is falling from a height h and it is rebounding after falling, and the coefficient of restitution is given to be E. If E is the coefficient of restitution, the total distance traveled before rebounding has stopped is. So we have here one particle which is falling from a height h. So here is a particle which is falling from height h. So we know that the velocity which will be attained after falling from the height h, that v will be under root of 2gh. If E is the coefficient of restitution, the velocity v1 with which it will rebound will be E times v, will be E times v. This will rebound with this velocity and go up one and then again fall. So while rebounding, as the velocity was v1, while it will come, then also the velocity will be v1, as it will just go up, the speed will be 0, and once again it will fall from the height. So we will see that it will first fall from height h, then it will rebound, go till some height h1 with this v1 velocity, then again fall back from h1, then again it will rebound with some velocity v2. It will go up some height h2, then come down. In this way, we need the sum of h plus h1 plus h2. So 2 times h1 plus 2 times h2. In this way, we need the sum. So this is what we have to calculate, and we have to get the values of h1, h2, and so on. So this will form a geometric progression we will see. Firstly, h1 we can calculate by the expression. As we know, v1 which it rebound, that is nothing but E times under root 2gh, and we will use the equations of motion v square equals to u square plus 2as. So in this case, finally when will it go up, then the velocity will be 0. So 0 equals u square plus 2as. So u square will be here E square into 2gh, E square into 2gh minus of 2 into g into h1, as the distance traveled in this case will be h1 and the acceleration due to gravity is g, the same, but minus g, because it will be decelerating when it will go up. So by solving this, we will get h1 equals to e square h. So h1 will be e square h, and in this way the series will go on. h2 will be again e square times of h1, e square times of h1, and in this way the series will go on. h2 will be e square. So we will need to add this series h1 h plus 2h1 plus 2h2 till infinity, because here the distance will keep on going smaller and smaller. So we will need to apply the formula of infinite GP, which is which is the sum for infinite GP, which is sum equals A by 1 minus R. E is the first term and R is the ratio. So in this case, if we will simplify this expression, it will become h plus 2he square plus 2 times h e to the power 4 plus 2 times h e to the power 6 and so on. This expression will be like this. So if we will calculate it, it's plus 2h if we will take common 2h e square. So we will get 1 plus e square plus e to the power 4 plus and so on the expression will be. So we will solve this by that formula of infinite dB 2h e square into 1 by 1 minus of e square. So if you will simplify this expression, it comes out to be h into 1 plus e square by 1 minus e square. So the answer is first option, which is h1 plus e square, 1 minus e square. Now here is the second question. In this question, a particle of mass m is moving in the x direction with speed 2v, is hit by another particle of mass 2m moving in the y direction with speed v. If the collision is perfectly inelastic, what is the percentage loss in the energy during the collision to the closest integer value? So we need to calculate the loss in the energy as the collision is perfectly inelastic. So there will be loss as it is in elastic collision. Perfectly inelastic it is given. So the masses which are colliding will stick after the collision. So firstly we will have m. We have m here, m, which is going in the x direction with speed 2v, and here is 2m, which is going up in the y direction with a speed v. So the collision will occur, and we will need to just conserve the momentum in the x direction, y direction. As we know, for collision, the momentum is conserved. So the initial momentum P initial can be written as 2mv 2mv I cap. So we are writing considering the coordinate system like this. This is x-axis, this is y-axis, positive y and positive x. And so 2mv I cap and P final. So 2mv I cap plus 2mv j cap, and then P final will be. So after collision, it will be like this, that this 3m mass will be there as the masses will stick. 3m mass will be there, and it will go somewhat like this because it will have a y component also and x component of velocity. So we can now say assume like p x I cap, py j cap, and comparing these values, we get that px will be 2mv and py will be 2mv as the momentum remains conserved. So now we need to calculate the energies. So K initial can be calculated by half mv square formula. So for this mass, half m into 2v whole square plus half into 2mv square. So it comes out to be 3mv square. Now K final. For K final, we can use the formula of kinetic energy, which is P square by 2m. So the total kinetic energy will be P x square plus Py square by 2 times mass. So kinetic energy P square by 2m. So Px square by 2 Px square plus Py square, which will be the net momentum square, Px square plus Py 4 divided by 2 times the mass. The mass here is 3m, 2 into 3m. So it will be 6m. And px square plus vy square is 2 times 2mv whole square, which is nothing but 4 to the 8mv square. 8mv square by 6m. So it will be 4 by 3mv square. 4 by 3mv square. And kinetic energy final is here. Kinetic energy initial is here. We need to just get the loss in kinetic energy. Loss will be K initial minus K final. And percentage losses also it will be percentage loss will be K final minus K initial divided by mod of K final minus K initial. So you need to solve this, and after solving this the answer comes. So the answer is 55.56%. 56% is the answer. And we need to give it for closest 20 years, so the answer rounded off will be 56. Now, in question number 63, it is asked that two particles of mass m and 2m, m and 2m are moving with speeds of 10 meter per second and 5 meter per second, as shown in the figure. They collide at the origin, and after that they move along the indicated directions with speed v1 and v2 respectively. The values of v1 and v2 are nearly. So the particles are colliding like this here, 10 meter per second, here 5 meter per second. They will collide at these angles, and after the collision, they will move away at the same angles with this horizontal with speed v1 and v2 respectively. So we are asked to calculate v1 and v2. So here is the solution. So in this question, we need to just apply momentum conservation in the x direction and the y direction, and we will get two equations from which we will solve v1 and v2. So the first equation is here, Px equals m into root 3 by 2 into 10. So the x component of the momentum is taken by m into the velocity is 10 meter per second into cos 30 degree, and 2m into 5 cos 45 degree, which comes out to be this. And py is calculated, which comes out to be m into 5 root 2 minus 5. This can be 10 into sine 30 degrees and minus of 2m into 5 into sine 45 degree. So the net momentum will be upside as 2m into pi by root 2 is greater and m into 5 is lesser. So this will be the momentum in x and y direction. We need to conserve it. The same equations are applied afterwards for the after the collision, taking the velocities v1 and v2. So then these equations come for py final and px final. So this px initial m into 5 root 3 plus 5 root 2 is equated to m into root 3 by 2 plus root 2 v2, and this m into 5 root 2 minus 5 is equated to m v1 by 2 minus root 2 m v2. So solving this equation p initial equals p final, we get the values of v1 and v2 to be 13.02 and 19.7. That is nothing but option number 3. Now the second question is regarding a pendulum which is executing simple harmonic motion, and its maximum kinetic energy is given to be K1. And if the length of the pendulum is doubled and it performs simple harmonic motion with the same angular amplitude as in the first case, its maximum kinetic energy is K2, relation between them. So it is asked that we have a pendulum of length L, mass M, and it is performing a motion, simple harmonic motion, and it is given that maximum kinetic energy, which is at the mean position. At the mean position, it will have maximum kinetic energy, and it is given that the maximum kinetic energy is equals k1. Now it is asked if the length of the pendulum is doubled and it performs simple harmonic motion. So the length of the pendulum is doubled. The length of the pendulum is doubled, and but the angular amplitude, that is theta, is kept same. So now we can have some relation for this kinetic energy, this maximum kinetic energy, as it is released from this amplitude theta. It will go down and its potential energy will decrease. If we consider u equals to 0 here and here u equals to u1, so delta k equals to minus delta u. This comes from the work energy theorem, as the work done by the gravity, or which is given by the negative of the change in potential energy, will be equal to the change in the kinetic energy. So the kinetic energy relation comes out to be mgl 1 minus cos theta, which is nothing but the negative of the change of the potential energy, which will be equal to the work done by the gravity, and this work done will be equal to the change in kinetic energy by the work energy theorem. So by this relation, we get that K E will be proportional to L. So as K is proportional to L, if the other factors are kept constant, then if L is doubled, then K will also double. So we get the answer to be option 2, which is K2 equals to 2K1. Now we have the third question. Fifth question here. Consider a pair of identical pendulums which oscillate with equal amplitude independently, such that when one pendulum is at its extreme position making an angle 2 degree to the right with the vertical, the other pendulum makes an angle 1 degree to the left of the vertical. What is the phase difference in degree between the pendulums? So it is given that we have a pendulum, since we have two identical pendulums. So as it is identical, the length of the rope, this thread, the mass of the bob, all everything will be same. And it is given that the amplitude of their oscillation is 2 degree, and it is given one of the pendulum is at 2 degree extreme position, and the other pendulum is at 1 degree towards the left. So now we have to calculate the phase difference between these pendulums. So there can be two methods to solve this. One is by this phasor method we can solve this question. In this method we compare the phasor, that is nothing but this, as in it is performing simple harmonic motion. So it can be considered to be a rotating vector, and if we will have light from here, if we will throw light from here, then this rotating vector's head will perform the shadow of this arrow head will perform SHM here. So the simple harmonic motion of a body can be compared with a rotating vector, that is called phasor. So with this we can have the phase difference relations. So we here considered at 0 degree, this is 0 degree. So at 0 degree, we will consider mean position, and the right extreme position will be at 90 degrees here at the top, and the left extreme position will be at here 270 degrees inside. So as it is given that first pendulum is at 2 degrees extreme position, right? So its phase will be 90 degrees. For the second pendulum, it is given that it is towards the left. So it is towards the left means it has crossed this mean position once again. This will go like this, and it will cross the mean position here, and it will come here. So it is at 1 degree amplitude. So if 2 degree amplitude is shown, it will be 1 degree. Then you can calculate that as the maximum amplitude is 2 degree, the length of this arrow will be 2 degree, this vector will be 2, magnitude will be 2 degrees and 1 degree. If this is, then the angle comes out to be 30 degrees from the horizontal. So it comes out 180 degree plus 30 degree, 210 degrees. So the phase difference will be 210 minus 90, 120 degrees. The second method for this question can be with the equations, means framing the equation that theta equals theta max sine omega t, and we just need to calculate this omega t, or which will be the angle. These angles we need to calculate. In the first case, if we will solve theta equals to 2 degree, theta equals to minus 1 degree, as it is to the left, means we consider the right side motion to be with the positive amplitude and the left with negative. So theta equals plus 2 degrees and theta equals minus 1 degree. And we put the value of theta max to be 2 degrees. At the extreme position, it has 2-degree angle. So solving these equations, we get the values of angles 90 degree and 210 degree. So the phase difference will be 120 degree. Now in the next question, the time period of oscillation of a simple pendulum of length L is T1, and the time period of oscillation of a uniform rod of same length L pivoted at one end and oscillating in a vertical plane is T2. Amplitude of oscillation in both cases is small, then T1 by T2 is. So as they are oscillating, and it is given that the amplitude of oscillation is small in both the cases. So here we can consider simple harmonic motion for the pendulums, and it is given that one is simple pendulum but the other is a compound pendulum, which is a rod which is hinged with one end point, and then it is rotating. It is oscillating in the vertical plane. So for simple pendulum, the formula for time period is 2 pi under root L by G. But for a compound pendulum where any rigid body is actually performing, whenever a rigid body is performing oscillations, then it form a compound pendulum. So here rod is this rigid body and it is performing the oscillations. And the formula for compound pendulum's time period is 2 pi under root I by mgl. Now here I is the moment of inertia of that rigid body which is given with respect to this axis. The axis around which it is performing the oscillation. So this axis will be actually perpendicular to this plane of the paper. So I have marked it with a cross. So it will be perpendicular to this plane of paper, and around this axis it is performing oscillation. So moment of inertia will be calculated around this axis, which is ml square by 3. And here the mgl, where m will be the mass of the rigid body, g is the acceleration due to gravity, and lcom is the length of the com, or you can say distance of the com from the hinge point. The distance will be taken, yes, from the hinge point the distance will be taken up to com, that is lcom, which in this case will be L by 2, as the length of the rod is L, and for a uniform rod we have that the center of mass is at the middle point, so it will be L by 2. And so putting these values, T2 comes out to be 2 pi under root L by G and multiplied with the factor root 2 by 3. And we were asked to calculate the ratio of T1 by T2, which comes out to be root 3 by 2, which is nothing but the option 4. Now, in the next question, it is asked a pendulum clock fitted with a small heavy bob that is connected with a metal rod is 3 seconds fast each day at a temperature 15 degrees centigrade, 2 seconds slow at temperature 30 degrees centigrade. Find the temperature at which it will show the correct time. So here firstly we will consider what is the relation between the temperature and the time period. Is the temperature and the time period, what is the relation? And then we will proceed for the question. So a pendulum clock is given, and for pendulum, as we saw, the time period's formula is 2 pi under root L by G. So here, as the temperature will affect only on the length of the rod, length of the pendulum. So we are concerned only with that thing that T is proportional to root of L. We are concerned with this fact. So we will take log both the sides and differentiate. So this is for getting the relation between the relative change of two quantities when we know proportionality. So we means mostly use this technique, that taking log both the sides on the LHS and RHS and differentiating, so that we get this delta term, which will be change in the quantity, and we will, as by this differentiation, we will get the relative change, and so the relation between the relative change. So it comes out delta t by t, where t is the time period and L is the length, equals half delta L by L. So this is the relation. Now we can uh, means have this relation in the context of temperature, as we have L. So L will be dependent on theta temperature. We have this relation delta L equals to L alpha delta theta by the heat expansion, means the expansion of the length due to the change in temperature. So delta L by L will be alpha delta theta. So we can write delta T by T equals to half alpha delta theta. So now we have got the relation. So we have two cases where the change delta T is given and delta theta is given. So we take the ratio of those two cases, plus 3 for 3 seconds faster and minus 2 for 2 seconds slower, and delta theta will be theta naught minus 15. Theta naught is taken to be the temperature where the clock has it is 0 seconds faster or 0 seconds slow, means it has no error, it is accurate. So theta naught is that at that temperature, and so delta theta will be theta naught minus 15 and theta naught minus 30 for the respective cases. And from this equation, we get that theta equals to 24 degrees centigrade. So the radii of two spheres of same material having density rho are in the ratio 1 is to 4, and their temperatures are in the ratio 24 is to 1. What will be the ratio of the heat contained in them? In this question, it is asked for the heat content ratio, where two spheres are given, and the ratio of the radii of, means the radius of two sphere having density rho is 1 is to 4 and the temperature ratio is 24 is to 1. So now this question is a little difficult to understand. It's the sometimes in questions this thing may happen, that there is not clear wording of the question, and we may have some difficulty to understand exactly what the question is asking. But by a little means observation, we can check that what it is actually asking, as we have given that the ratio of temperatures and radius. So, and actually here the ratio of temperatures means we can actually say that this is the ratio of the change in temperature, because as it is asking for heat content, it is actually saying or relating to the heat which is absorbed when means like when the object is given heat and its temperature rises to that heat which is provided, that heat content or that heat which is absorbed, the ratio of heat that is asked is that. So the temperatures ratio is actually the change in temperatures ratio. That is, it is not the ratio of temperatures, but change in temperature. So we have this relation that Q is equals to ms delta T or mc delta T, where m is the mass, c or s can be the is actually the specific heat capacity of that object, of that material, and delta theta is the change in temperature. And in this case, the object is sphere, so the volume, rho times volume. Rho is the density and volume will be 4 by 3 pi r cube. So by this relation, we have the relation for heat which is absorbed. So we see that Q is proportional to R cube and to change in temperature. So we just take Q1 by Q2's ratio, R1 by 2 whole cube by delta theta 1 by delta theta 2. So putting the values of these ratios, one is to 4 and the other is 24. It comes out to be 0.38 approximately. Now the next question asks the amount of heat required to freeze 45 gram of water at 6 degrees centigrade to 0 degree centigrade ice. So the change in temperature is from 6 degree to 0 degree, and then the formation of ice is there. So here it is H equals mc delta T plus ml fusion. So this is, we can say, the general expression for the heat absorbed by any material, where here m is the mass of that material like water. C is the specific heat capacity, delta T is the change in temperature. Then here, this is the specific heat which is absorbed, which for the change in temperature, and ml fusion. L is the latent heat of fusion, which is required for the change in the state of that, means changing state from ice, water to ice in this case. So we need to just put the values of C, delta T and M. So here it is given that mass of water is 4.5 gram, which we will take in the SI units 4.5 into 10 to the power minus 3 kilograms. And C is given 4190 joules per kg per Kelvin into delta T is 6 plus latent heat of fusion. It is given that 3.33 into 10 to the power 5 joules per kg. Solving this, we get 1611.6 joules to be the answer, which is nothing but option 2. Now the question number 70, here we need to calculate the ratio. Here it is asked that magnitude of magnetic induction at one end of the solenoid of 100 turns and a total length of 50 centimeter if it carries a current of 2.5 amperes. So we know that the formula for the magnitude of magnetic induction at one end of the solenoid of 100 turns, and so for the solenoid the value of magnetic field magnetic induction's magnitude is given by mu into NIL, where mu is k mu 0, k is the relative permeability and mu naught is the absolute permeability, which is nothing but 4 pi into 10 to the power minus 7. And here n is the number of turns in that solenoid, I is the current which is passed, and L is the length of the solenoid. But this magnitude would be at the center. But here in the question it is asked at one of the end of the solenoid. At the ends it becomes half of the center's value, so it will be mu and IL by 2. So putting the values of the given quantities mu and IL, we get the value of P to be 1.57 10 power minus 4 Tesla, which is option 3. Now in the question number 71, the current I in a coil varies with time as shown in the figure. The variation of the induced EMF with time would be. So the current I is given, the variation of I versus T plot is given. Now it varies in a coil. Coil has some inductance, self-inductance, and due to that there will be a generation of induced EMF, when the current changes. So that the relation induced EMF denoted here by this E. Induced EMF equals minus L di by dt, where L is the self-inductance and di by dt is the rate of change of, is minus L di by dt because the self-inductance, because this induced EMF will try to oppose the change in current, so it will be minus L di by dt. Now, in this question, as di by dt can be calculated from the slope of the plot, as the plot is I versus t, so di by dt will definitely be slope. So just by the slope, we will have the idea of what kind of curve it will be for the what kind of plot it will be for EMF versus time. So as the slope in the region 0 to t, so time from t 0 to t equals t by 4, the slope is positive. So as the slope is positive, induced EMF will be negative, and it will be a constant value because the slopes is also having a constant value. So the option which matches is only option number one. And also from t by 4 to t by 2, it will be 0 as the slope is 0. And from t by 2 to t by 4, the value will be positive as the slope is negative. So the option number one is the answer. Question number 72. An equilateral triangular loop ADC having some resistance is pulled with a constant velocity v out of a uniform magnetic field directed into the screen at time t equals to 0 is at the edge of the magnetic field. So the induced current I versus T graph will be as. So here some graphs are given the options. We have to means deduce which graph will come. So here we have a loop which is with a constant velocity moving in a uniform magnetic field. So the magnetic field is uniform and it is having constant value. So the velocity is also having constant value. Now we know one thing that when through a closed loop, there is variation of the magnetic flux due to the magnetic field, which is given by mag- the magnitude of magnetic field B into area vector B dot A in the dot product of B vector and A vector. So that will be the flux, and the change in flux will generate a induced EMF. But as it is said that the at t is equals to 0 at this moment, the starting moment, the side DC of the loop is at the edge. Because if it is the loop is just moving in this uniform field and it is somewhere inside it, then there will be no change of the flux as the velocity is constant and also the magnetic field is also constant. So there will be no induced EMF. But as at t is equals to 0, the side DC is at the edge of the magnetic field and it will soon start coming out of the magnetic field. So the area which is in the magnetic field will go on decreasing and so the flux will change. So here we have the relation E is equals to minus d phi by dt equals minus dA by b dA by dt, where b is the magnitude of the magnetic field and dA by dt is the rate of change of area. Now here area can be h minus calculated h minus vt whole square by root 3 is the expression for area. So as equilateral triangle was given and in t time it will cover vt distance. So the height of the equilateral triangle which will be left in the magnetic field will be h minus of vt, and for the area we have this formula, and from this area comes out to be h minus vt whole square by root 3. So minus dA by dt comes out to be 2h minus vt into v by root 3. So the induced EMF will have this value by putting the values in this formula, and so the induced current will be E by R. So we need, so here velocity is constant, B is constant. With time, it will be a linear plot. As we can see, it is having a equation of the line. E is I is plotted on the y-axis and x-axis we have time t. So it will have a positive y-intercept and it will be then decreasing. So linear plot will be there. So option number 2 is the correct answer. Question number 73. In Young's double slit experiment, relative intensity at a point on the screen may be defined as the ratio of the intensity at that point to the maximum intensity on the screen. Light of the wavelength 7500 angstrom passing through a double slit produce interference pattern of relative intensity variation as shown in the figure. on the horizontal axis represents the angular position of a point on the screen. Then the ratio of the amplitudes of the two waves producing interference pattern on the screen is. So here in this curve, it is showing relative intensity versus the angular position of that point of on the screen where the interference value is given, relative intensity value is given, and here the angular position is given. So maximum intensity is I and the minimum intensity is I by 9. So we have this relation which says root I1 plus root I2, where I1 and I2 are the intensities of the two interfering lights. As we have two slits, the intensities of the light waves which are coming from the two slits can be considered as I1 and I2. So this relation is there for intensities, maximum intensities and minimum intensities on the screen due to the constructive interference and destructive interference. And this is the relation root I1 plus root I2 by root I1 minus root I2 whole square equals to I max by I min. So this comes out to be 9 because in this case I max is I and I min is I by 9. So the ratio comes out to be 9. So solving this, we have the ratio of I1 by I2, which is the ratio of intensity is 4, and we know that the intensity is proportional to amplitude square, or we can say the other way around that amplitude's ratio is equals to the square root of intensity, so it will come up to be 2. Now question number 74. Here also YDSC double experiment is there. Spacing between the two slits is 0.1 mm. If the screen is kept at a distance 1 meter from the slits and the wavelength of the light is 5000 angstrom, and the fringe width is. So we are asked fringe width which is beta. I have shown here. So for fringe width we have formula beta equals to lambda d by d, where lambda is the wavelength of the light which is used of the wave. D is the capital D is the distance between the screen and the double slits, and the small d is the distance which is between the slits, the two slits which are there. So it is the distance between them. So we need to just put the values of lambda d by d, and we'll get the answer, which is option number 3, 0.5 centimeters. Question number 75. Two slits are separated by a distance of 0.5 mm and illuminated by light of wavelength lambda 6000 angstrom. If the screen is placed at 2.5 meters from the slits, the distance of the third bright fringe from the center will be. So delta x equals and lambda equals yd by d. So this is the relation for YDSC, the standard Young's double slit experimental setup. We have delta x, the difference between the distance traveled by the waves, that is nothing but delta x, which should be equals to n lambda for constructive interference, or for the bright fringe to form. We need the change in distance to be equal to n lambda, where lambda is the wavelength and n is a natural number, and it is equals to yd by d, where y is the distance from the central bright fringe, from the center of the screen where the central bright fringe is, from there to the position where the bright fringe will form due to that delta x. D is the distance between the slits, and small d is the distance between the slits, and the capital D is the distance between the screen and the slits. So just putting the values of n equals to 3, as we need the distance of the third bright fringe. Lambda's value, we will get y equals to 90 into 10 to the power minus 4, which is nothing but 9m, option 4. Now question number 76, the electric potential at a point x comma y in the xy plane is given by v equals to minus kxy. So in the XY plane, the electric potential is given, and electric field intensity at a distance r from the origin varies as. So now it is asked for the variation of electric field intensity with respect to r, but it is given with respect to x comma y. So we need to convert this x comma y's relation to r theta relation, where x comma y are of the Cartesian coordinate and r theta are of the polar coordinate. So for the change from Cartesian coordinate to the polar coordinate, we have this relation x equals to r cos theta. So for any point like here, for any point x comma y in the Cartesian coordinates, and here r is the distance from the origin, and theta is this angle. So we can see r cos theta equals the x coordinate and r sin theta equals y coordinate. So just put these values, and it is asking the variation with respect to r. So we will assume theta to be constant, and we'll differentiate it with respect to r, which comes out to minus k sin theta cos theta into 2 times r. But as we know, theta is constant, so electric field, which is nothing but minus dV by dr, where v is the potential, it will be proportional to r from this relation. So the option number 2 is correct answer. In the next question, we are given in an electric circuit, a battery is connected to pass 20 coulombs of charge through it in a given certain time. The potential difference between the two plates of the battery is maintained at 15 volts. The work done by the battery is in joules. So this is a very simple question which is based on just a fundamental concept that is of electrostatics, that what is the electric potential. So the potential difference, the electric potential is due to the work done on the charge. So it is defined as the work done required per unit charge. Work done per unit charge is nothing but the potential. So delta V equals W by Q. So the work done will be Q in delta V, which is nothing but 20 coulombs into 15 volts, 300 joules. The answer is 300. Now, question number 78. We are given three identical large plates of area A are at distance 2D and D. D is much less than the length of plates from each other. Metal plate A is uncharged, while metal plates B and C have respective charges plus Q and minus Q. Metal plates A and C are connected by switch K through wire. The heat produced by after closing the switch K is. So three plates are given. The plates B and C will have charge from their inner sides plus Q and minus Q. So we have capacitance system, the parallel plates capacitor system. We have one wire from A, one wire from C, and it is said that we'll close this switch, this key, and after that we need to calculate the change. Means we need to reduce the change and what will be the heat produced due to the distribution of charges which will happen after closing the switch. So for this parallel plate capacitor system, we know the formula for parallel plate capacitor C equals to K epsilon naught A by D, where epsilon naught is the permittivity of free space, K is the relative permittivity, E is the area, and D is the area of the parallel plates, and D is the distance between the plates. So we can have a system circuit as like this. After closing the key, means just after closing the key, the circuit will look like this somewhat. Means so we have considered here C1 equals to epsilon naught A by 2D. This for this capacitor, we have considered C1 equals to epsilon naught 2D. The C2 equals to epsilon naught A by D, which is this capacitor, which comes out to be 2 times C1. So this is the 2 times C1 capacitor, this is C1 capacitor. Here the charges are firstly are on this 2 C1 capacitor, minus Q and plus Q. In the steady state, the charges will be redistributed. Here it will be Q1 minus Q1, and as Q1 charge is here, the rest of the charge, as the charge will be conserved, it will not be destroyed. The charge initial and charge final will be saved. So on this plate, which is connected to this plate, so this part of this circuit will have plus Q charge conserved. So it is Q1. So here it will be Q minus Q1, and similarly the negative charges will be there. So in the steady state, uh, for obtaining the relation for Q1, for the equation for Q1. So it will be VC1 equals to V2C1. So both capacitors will have equal potential in the steady state. So we have just V by C equals Q by C is equals to potential difference between the two plates, and so the difference will be same. Solving, we come with that Q1 equals to 2Q by 3. So 2Q by 3 is the charge which will be on the 2C1 capacitor, and C1 capacitor will have Q by 3 charge. Now for energies, we need to calculate the energy initial which is stored in the capacitor. Energy initial which is stored in the capacitor. For the energy stored in the capacitor, we have formula Q square by 2C. As initial charge is Q whole square by 2 times the capacitor value 2C1, which is Q square by 4C1. Energy final will be for both the capacitors, some charges will be there, 2Q by 3 and Q by 3. Respectively, so having this formula, we have E energy final equals to Q square by 6C1. Now the delta E will be E initial minus E final Q square by 2L C1. Now we put the value of C1 epsilon naught A by 2D. So we have Q square D by 6 epsilon naught A. And now in the question, here one variable was given as the value of heat loss heat produced is Q square D by P epsilon naught A, and we need to compare this with other Q square D by 6 epsilon naught A. So P's value will be 6. Now two loudspeakers L1 and L2 are driven by a common oscillator and amplifier are arranged as shown. The frequency of the oscillator is gradually increased from 0, and the detector D1 and the detector D records a series of maxima and minima. If the speed of the sound is 330 meters per second, then at what frequency in hertz does the first maximum is observed? So it is a question of interference of the sound waves, and as we know, for interference we need the phase difference between we need the two coherent sources for the interference to occur in the waves, in the sound waves. So for coherence, we are given that a common oscillator and amplifier will be generating these sound waves, and for the speakers driven by that oscillator L1 and L2 are this loudspeakers. So, and it is given the distance between here, the figure is 9 meters, and the detector is kept at 40 meters straight from L1. So by Pythagoras theorem, we can calculate this hypotenuse, which will be the distance between L2 and D, which comes out to be 41 meters. And 40 meters is the distance given between L1D, L2D minus L1D, which will be the delta X, which is the needed quantity for interference is 1 meter. And for interference, we have delta X equals to N lambda. And it is said that the frequency of the oscillator is gradually increased from 0, and the detector records the maximum and minima. So we are asked the frequency at which the first maximum observed. So as the frequency is increased, some maximums will come. The first maximum will come at the minimum frequency, which will be there. So for minimum frequency, as the frequencies relation come out to NV by delta x, where V is the velocity of the sound and is a whole number 0, 1, 2, 3, is a natural number 1, 2, 3, 4, and delta x is the distance. Sorry, the difference in the distance traveled by the waves. So for minimum frequency n equals to 1. So f equals to v by delta x as we put the value of n equals to 1 for minimum frequency. So the answer comes out to be 330 Hz. Now the second question, it is a very straight-ahead question which needs just only a formula for things to be remembered. So it is very important always to remember all the formula, as sometimes the straight-ahead questions come and there are many formulas. So if the formula is not remembered, then there might be a difficulty. Like in this question, it is given bulk modulus of water is 2100 megapascal. The speed of the sound in water is asked, and the density of water is given to be 1000 kg per cubic meter. So if this formula is not known, then this question will be of no use, since this simple question will not be solved. So it is very necessary to remember all the formula. So V equals to under root V by rho is the formula. Just give the value of 2100 megapascal and rho 1000 kg per cubic meter, and you will get the answer to the option 2. Now question number 81. Here a source and the detector both starts moving simultaneously from the position shown in the figure, one along the x-axis and the other along the y-axis with speed 40 meter per second and 30 meter per second respectively. If n is the frequency of the source, then the graph between the apparent frequency observed by the detector and the time would be. Assume that the source and the detector do not collide. So here in the figure, it is shown how the mechanism is, means the source is coming from here 40 meters per second. It is at a distance 40 meters from this O point, and the detector is from at 30-meter distance coming with the velocity 30 meters per second. This velocities are constant. These are coming like this. They will meet here at O, but they will not collide and they will go on. So for this journey, we are given 4 graphs. We are asked, these graphs are for n, where n is the frequency, and dash is the apparent frequency. Due to this motion, there will be change in the frequency. Means, the detector will detect an apparent frequency due to the relative motion which is happening between the source and the detector. And with time t, we need to plot the graph. So here 4 graphs are given. Now, as we know, the formula for F apparent is V plus minus VO by V plus minus VS, F actual, F apparent, and this is F actual. And V is here the velocity of the sound. VO and VS are the velocities of observer and the source respectively. So in this case, observer is the detector and the source is the source, which is moving with 40 meters per second. So this plus minus depend on the case. So we always remember one thing, that whenever the relative motion is such, that means like if observer is coming towards the source, then the apparent frequency will increase, and it is obvious and we have its interpretation. So by that we know that in this case the apparent frequency will increase, so the numerator should increase. So in that case we take plus in the numerator, and when the observer is going in the opposite direction away from the source, then minus sign is taken because the F apparent will decrease in that case. And in the denominator, the case is reverse. When the source is coming towards the observer, in that case, the frequency will increase because the relative motion says that they are coming closer. So the F apparent is greater than the F actual. But in that case, as it is the quantity in denominator, we take minus sign. And when the source is going away from the observer, then we take the plus sign. So in this way, we take the signs. Uh, we just see what the case is, where the frequency will increase by this motion of the source and observer, and according to that we use this formula. And in this case, this formula is for the relative motion along the line which is joining the two bodies. If here it is the source, here it is the observer, source and observer. So the straight line which connects two of them. So the motion which is along this line, that is the relative motion which is we are concerned with. The perpendicular motion is of no use in changing the frequency for the apparent frequency. So in this case, actually, as the velocity is constant, we come to this relation that this theta, which is between the line joining and the x-axis, the line joining the source and the detector, which are shown by S and D, S dash and D dash at a later time. So this theta is constant actually because the velocities are constant. Uh, we can have the relation for theta tan inverse OD dash minus O by OS dash. OD dash comes 30 meters minus 30 into T1, which is the distance traveled by the detector. So 40 minus 40 T1. But this comes out to be tan inverse 3 by 4, which will be constant. So as the theta is constant, the components of velocities which will be of the source and the detector along this line, along the line which is joining, along this line which is, so as the theta is constant, the components of velocities which will be along this line joining them as d will be same, and so when we put these values till they meet, this condition will hold, and as apparent will be this expression which will be greater than the f actual. But after at the instant when they meet, they are at the same position, so f apparent will get equals to f actual. And after they meet, they will go away, means like D will go in this direction and S will go in this direction. And in this case, they will be moving away from each other. So the expression for F parent will be like this, and it will be less than the F actual. But whatever the case may be, the frequency is constant. So firstly, the frequency is higher than for a small instant at that, just for that t is equals to some t2, where when they meet at this point O, the f apparent is equal to f actual and f apparent is then over. So the graph which is correct is option 1, as here n dash, it is some higher frequency than n, which will be constant. Then at just one instant, it will be n somewhere here, and after that, for instantaneously, it will change to n double dash, which will be lower than n. So the option 1 is the correct answer. Now here is a question from waves of string. So traveling wave pulse, we have one equation given for the wave, y equals to 4 by 3x square plus 48 t square plus 24xt plus 2, where x and y are in meters and t is in second. The velocity of the wave is. So for this, for the waves, we have this relation between, for the equation of wave, we have this relation that, as we know that equation of any wave is given by y, which is function of this, the oscillation of the particles of the wave at any time. The amplitude y is given as function of x and t. So we have this relation, partial differentiation. Del here is for partial differentiation. Del y by del x equals minus 1 by v del y by del t. This is the relation, and we need the help of this relation for solving this question. We calculate del y by del x. We calculate del y by del t. These are the values of del y by del x and del y by del t. We put these values here, and from this v comes out to minus 4 meter per second, means that the wave is going, minus corresponds to the thing that the wave is going in the negative x direction. If it comes out to positive, then it is going in the positive x direction, and the value comes out to 4. The value comes out to 4, so the answer is 4 meter per second. Now 83 is a very simple question. Here the equation of wave is given, and the values and it is given that CGS units are used for this expression, and the values of t and x are given. We have to just put the values in this relation, y is equals to this, and y comes out to be 2 centimeters. So the answer is option 2. In question 84, the percentage increase in the speed of the transverse waves produced in a stretched string if the tension is increased by 4% will be. Now we have this relation v equals to under root t by mu, the relation between velocity for the transverse waves, and here T is the tension and mu is the linear mass density, mass per unit length, linear mass density of that string over which the stretched string over which the transverse wave is there. So this relation we consider mu is to be constant in this case, and tension is varying, so we need the relation for V and T. As we saw earlier also in one question, that for relation between the relative changes, we take log on the both LHS and RHS and we differentiate in both the sides. We get the relation between the relative changes of the physical quantities del V by delta V by V equals to half delta T by T, means if the change in tension is 4%, the half of 4%, 2% will be change in the velocity of that wave. So 2 is the answer. Now the next question is a bob of density sigma equals 12 gram per cubic centimeter is suspended with a massless string of length L equals to 1 meter. When it is immersed in liquid of density rho equals to 2 gram per cubic centimeter, its time period of oscillation is dash hertz. So here it is a little mistake in this question. This is not hertz. This is actually seconds, as the time period, the assigned rate of time will be seconds. This hertz is a printing mistake. So time period is asked, and we are given top density sigma and the string length L equals to 1 meter and rho to be 2 gram per cubic centimeter. Value of root 3, which may be required, is given as 1.7 for calculations. Now in this question we will learn one concept of G effective. As for pendulum, we know that the only forces which are acting on it are the tension due to the string and this mg. So the whole motion is decided by this mg, as this is the force which is acting on this pendulum externally. So this mg governs the motion, and the time period comes out to be 2 pi under root L by G. So we can actually change any case to the case of just mg. Like in this case, the bob is immersed in the liquid and it will be having two forces, mg downwards and F buoyant force due to the liquid upside. So in that case, we can compare it to the case having some mg effective as downside. There's the F net, which will be fg minus fb. mg minus fb we will equate it to the mg effective so that we can relate this special case, this new case, to the simpler case which we know, which is just one force mg acting. So mg effective will be mg minus fp. So the relation comes out rho s and vs. Here s is for the solid, which is the bob, and L is for the liquid. So rho s vs g effective equals rho s vs into g minus rho L Vs into G, which is the relation for buoyant force. So calculating this G effective comes out to be rho S minus rho L by rho S. So we can consider this whole case where the two forces mg is acting downwards, F buoyant is acting upwards, to be a case where the G is slightly less. The G is the G effective 5 by 6 times of G. The motion which will occur will be same in both the cases. As mathematically we will arrive at the same expression because the G effective will act like mg minus fp. Mg effective will like mg minus fp. So the time period will be 2 pi under root L by G effective, and L in this case will be 1 meter, and as it is given in the question, and G effective is 5 by 6 times of G, which is 25 by 3 meters per second square. And just putting the values, the answer come out to be 2.135, root 3 value 1.7, and pi 3.14, so the value comes out to 2.135 seconds. Now the atmospheric pressure at the bottom of a tank of water is 3p, where p is the atmospheric pressure. If the water is drawn out till the level of water is lowered by 1/5, the pressure at the bottom of the tank will now be. So it is given, we have 3p, the pressure at the bottom of a water tank, and p is the atmospheric pressure. Now the pressure at the bottom of the tank will be pressure due to the atmosphere plus pressure due to the water, so it is P atm plus P water. But P atm is given to be P, and so the P water will be from P initial 3p equals P plus P water. P water comes out to be 2p, and this 2p will actually be equal to rho gh if we'll consider that initially the water tank there h height amount of water was given. So rho gh, we know the pressure at height h or the depth h due to water is rho gh. So this pressure equals to 2p at the bottom. But now it is said that the level of the water is little decreased. The level is lowered by 1/5, so the height becomes 4/5 as 1/5 of the height is reduced. So the new pressure of the water at the bottom will be rho g into 4 by 5 h. Now rho gh equals 2p, we will substitute it here, and 4 by 5 into 2p equals 8 by 5p. So the new pressure just due to the water at the bottom will be 8p by 5, which was initially 2p, and we will add the p atmospheric pressure in that 8p by 5 plus p. 13p by 5 is the total pressure due to the atmosphere and the water at the bottom after that change. So the answer is option 2. Now in this question, a ball whose density is 0.4 per 3 kg per cubic meter falls into water from a height 9 centimeter. The depth to which the ball sinks is dash centimeter. So we are given a ball, and it is falling from a height, and g is the acceleration due to gravity. Here we have shown the interface of the liquid and air. So it will fall in water from here. So as it falls, V1 will consider the velocity which is just when it touches the water. Now till it comes till water, it is having acceleration due to gravity to be g. But after that, the net force which will be acting due to mg and the buoyant force due to gravity, which is mg minus f buoyant, which is the buoyant force due to the water which will be upside. So the buoyant force in this case will be greater, as we will see. due to the much higher density of water than the solid. So the F net comes out to be upwards. It's Fg minus Fb. So we calculate this F net and the acceleration. In this case, it will be deceleration actually, as the acceleration comes out to be negative as it is upside. Acceleration will be F net minus m. F net is rho s into Vs into g minus rho l Vs g by m, where m is the mass, rho s Vs are the uh, density of the solid, volume of the solid, and rho l is the volume density of the liquid. Density of the liquid in this case will be 1 into 10 to the power 3 kg per cubic meter, as it is the standard density of the water, which we mostly consider as the liquid is water. So the expression for the deceleration or the acceleration, which is negative 0.4 minus 1 by 0.4, it comes, keeping the values of rho s, rho l by rho s, Vs cancels out. So it comes out to 0.1 minus 0.4 into g, which is 1 minus 1.5 g. So the delay deceleration will be 1.5 g. The velocity which was attained was under root 2 gh. Now again we apply this equation v square equals to u square plus 2as. To put the values, the final velocity will be 0, as the ball will keep on decelerating as it goes on sinking, and it will travel a certain distance, and after that the velocity will be 0. We have kept the values of initial velocity under 2gh. The deceleration acceleration will be minus 1.5 g, and s will be the distance traveled, the depth which it has covered, which we need to calculate, which comes out to be 2 times h by 3, where h was the original height, and original height was 9 centimeters, so 2 by 3 times the original height comes out to be 6 centimeters. Now here in the next question, it is asked a point mass is placed at a distance A from one end of the rod of mass m and length L on the line which passes through the central axis of the rod, and the potential energy of the system is asked. So we have a point mass here, and we have a rod of length L. A rod is there and mass capital M. It is said that along the axis which passes through the central axis of the rod, along this line the small mass, point mass M, is kept, which is at a distance A from one end of this rod. It is given. Then the potential energy of the system is asked. So for potential energy, we will consider the formula Gm in Gm1 M2 by R, where minus Gm1 M2 by R. This formula we will consider minus Gm1 M2 by R for the potential energy for 2 point masses. But here one rod is given, so for this we need to perform integration for the small element, assuming that small element of dx length. We will apply this formula minus gm1 into by r for the small element, and hence the potential energy of interaction will calculate. So for this mass of this dx length, we will calculate the mass per unit length m by L, and then the mass dm of the small element of length dx will be m by L into dx. So g m1, that is nothing but m2 m by L into dx by the distance we have considered here x, and then we have taken dx element. So the distance is x minus g m1 m2 by x, and we'll integrate this potential energy from A to A plus L. The limits will be as the x varies from A, x equals to A, to x equals to A plus L, these two endpoints. And the relation comes out to be minus G M M small m capital N by L ln is log to the base P, or the natural logarithm of A plus L by L, where A is the distance, this distance from point mass to this end, and L is the length of the rod. Now we have question number 89. The binding energy of the satellite of mass m in an orbit of radius r is. So the binding energy is actually in the reference to the total energy. total energy T, the motion of any, from the knowledge of the gravitation, we know the motion of any body which is revolving around another body. So here the satellite is revolving around the Earth. So for that we know the relations for total energy in the circular orbit, total energy, then the potential energy, kinetic energy. So the binding energy is related to the total energy of this system. Actually, it is having it is a bounded system, as we know. Whenever a satellite rotates on around Earth, it is having a bounded system. It will not go into the free space, or it will not be. It is under the influence of the gravitational force due to the Earth. It is actually bounded to Earth, and so the total energy comes out to be negative. The binding energy is therefore the term binding is used, and binding energy will be negative of T, as because the total energy of the system, if will provide extra T amount of energy, so the total energy will become minus T plus T, the extra amount of energy, the total energy becomes zero or just greater than T, the small amount also, then the energy will become greater than equals to zero. The total energy will become greater than equal to zero, and so the system will not remain bounded, and it will leave the Earth. The satellite will leave the Earth. So that's the concept of binding energy, which is keeping the satellite bounded to the Earth or any system of such two bodies. So that's the binding energy, and it was negative of T, as it is the amount of energy which is needed to be given to, uh, or it is that amount of energy which we can say released when the system is formed of a bounded system is formed. So minus T, so it will be minus of minus GMM by 2R, where GMM by 2R is the energy, total energy expression we know in this case, and R is the distance between the Earth and the satellite. But here we are given the expression for acceleration due to gravity, which is gm by r square. We know where r is the radius of the Earth, g is the universal gravitational constant, and is the mass of the Earth. So gm comes out to be gr square. Putting this value in this expression, the option 2 matches. So the answer is option 2. Now the last question is question number 90. In this question, a solid cylinder is given, infinitely long solid cylinder of radius r having a uniform density. The gravitational field at a distance r1 is E1, at a distance r2 is E2. For this question, one important concept which we need to know is of the electrostatics, is that the electric field variation for a solid cylinder inside the solid cylinder and outside the solid cylinder. So the value of the electric field inside the solid cylinder at any point A, if you consider, and if from the central axis, the distance of this A point, from the central axis, where the distance of this A point is RA, if we denote it to be RA, then the electric field inside at any point A is given as rho RA by 2 epsilon naught, where epsilon naught is the permittivity of free space, and rho here is nothing but the charge density of this infinitely long solid cylinder. So as we know, the uniformity of electric field or gravitational field, we can extend this same formula of electrostatics to gravitational field. So may it be gravitational field or electric field, as the variation is of 1 by r square for the force gmm by r square, or kq1 q2 by r square. We have the relations for the Coulomb force or the gravitational force. The variation is for the both these forces is same. So may it be gravitational field or electric field, there is the similarity. So the variation is proportional to R inside, and outside the variation will is proportional to 1 by R, which comes out that as we know, for a infinitely long line of charge, the if lambda is its charge density, charge per unit length, and key is 1 by 4 pi epsilon naught, then electric field at any distance, any point which is at a perpendicular distance RB, any B point out is given as 2k lambda by RB. Here we use this similarity considering this solid cylinder to be a line of infinite line of charge, and we calculate the lambda equivalent by this relation that lambda equivalent into length will be the total charge, and rho, which is the charge density, into pi r square L, which is the volume of the solid cylinder. This charges will be equal. So from this lambda equivalent is calculated, and we have the relation for electric field. So the same will be for gravitational field. So in that case, variation outside is 1 proportional to 1 by R. The variation outside is proportional to 1 by R, and the variation inside is proportional to R. So if we plot a simple graph of the field with respect to R, it will be like up to the radius of the solid cylinder, it will be linear graph, which will be increasing proportional to R. Then it will be 1 by R variation. So after knowing this, we will see the options. Then both the option 1 and option 2 are true, because inside, when R2 is R1, R2 are less than R, the electric field will definitely be lesser when the radius lesser, the distance will be lesser. But the outer case is exactly opposite. When the distance is greater, the electric field is lower. So both options are true. So the option number 3, both 1 and 2 is correct in this case. Now this was the last question of this physics section, question number 90. So that was it. Thank you.